Welcome to Triad Drones. Today we will teach you how to properly plan an autonomous mission in Q Ground Control. Download QGC if you don't have it already. Open the program. On the main screen, click on the Plan tab. Zoom in on the map while on Plan screen to locate your area of interest. Determine what type of grid that you want to create. For this example, we will do a survey scan. Select the Takeoff tab on the left side of the screen. While the Takeoff tab is highlighted, click on the map where you anticipate the takeoff position will be. On the right side of the screen, set an altitude for takeoff. You will have to determine how high to set to avoid any obstructions. For this purpose, we will set altitude to 50 meters. Each mission will be different depending on what equipment or payload you are working with. For this example, we will be flying with a LiDAR sensor, and will require a figure 8 initialization before and after you scan your area of interest. We will create our mission accordingly. On the left side of the screen, press the Waypoint tab. Once the Waypoint tab is highlighted, you will be able to set your mission waypoints. Begin writing your initialization by creating a clean figure 8 or an hourglass, making certain to not write any acute angles throughout your mission. Angles under 90 degrees will cause inconsistencies in smooth flight and will negatively affect the data that you ultimately collect. For this example, the initialization has been accomplished using 9 waypoints. After you have your initialization written, you will create your survey grid. On the left of the screen below the Waypoint tab, select Pattern, then select Survey. Then select Basic on top of the screen. Once the green survey grid appears on screen, click and drag the white circles on the corners of your grid to adjust for your area of interest. The white lines in the green grid box will be the vehicle's actual lines of flight. You can adjust your line spacing, altitude and speed of the mission in the Survey tab on the right of the screen. For LiDAR scans, we typically recommend 50-meter spacing, 50-meter altitude, 5 meters per second speed, and camera triggers every 5 seconds for the best results. However, be aware of the recommendations of your equipment and adjust accordingly. After you have your grid set, we suggest making a waypoint prior to the entrance of your scan grid and adjust the speed of the flight from 10 to 5 meters per second. After the exit waypoint of the survey grid, select the Waypoint tab on the left of the screen and create another figure 8 finalization comparable to the initial one. Remember to create a clean path using no acute angles. After the finalization of the figure 8, create a clean path close to your initial takeoff point. If there isn't a return to launch function already set, create a final waypoint and select the white drop-down arrow to change the function from waypoint to return to launch. After you review your mission and are satisfied, select the File tab on the left side of the page and select Save As. This will create a .plan file that you can reference and apply to future flights. Congratulations, you have now successfully created a mission for an autonomous flight. Visit triaddrones.com to learn more about our vehicles, services, and solutions that we provide.